Yes, to kick things off, I do of course want to make sure my clicker is working. It's not. I'll return to the lectern. We love technology. All right. So, first thing, of course, is I do, of course, want to pay tradition acknowledgement to the First Nations people who inhabit this land. So, obviously, we're here on the beautiful banks of the Yarra Valley on the lands of the Wurundjeri people. And it's amazing to think about the fact that for tens of thousands of years they inhabited this land, that they lived their life upon this river. And now today we're upon this beautiful land as well. I'm very pleased to have woken up on this land, to have made this presentation on this land. And I pay my respects to First Nations people, past, present and emerging, and those here with us today. So, who the hell am I and what am I doing here? All the normal picture things, bit of an explanation. So, yes, my name's Stephen Sennett, bit of background on me. So, I'm a senior consultant specialising in cloud with a company called Kinetic IT. I'm also a course author with A Cloud Guru and an AWS community hero. Find me on LinkedIn, and I am a local Melburnian. Go Melbourne, better than Sydney! There we go. Oh, we hyped the energy up. All right, awesome. Now, next bit, I'm going to ask some questions from the room. Now, this bit is just going to be a show of hands, so don't worry, I'm not going to be trying to drag too much energy out of people. I do want to get a bit of a sense out of the audience, though. First of all, how many people here are individual contributors versus people managers? Now, in the sense of this, an individual contributor, for people who might not be aware, people who don't have people reporting to them on a daily basis. You're not having to worry about people's sick leave, their performance management, their recruitment, all that sort of thing. If you're a people manager, you are managing people on a daily basis. So, individual contributors, raise your hands. Woo, there we go, hard workers. All right, and the people managers, do we have any people managers? Excellent, the people who keep us honest. Awesome. So, what's today about? Today really is about some of the practical tools which we can use in our roles when it comes to making decisions within the complex world. This is something I hope will be useful to everyone. For people who are just starting out their career, this is something I guess will help you have the understanding and ability to interpret some of the decisions that are made, and also some of the abilities to understand how you can influence decisions as well. For people who are at the middle of their career, they're wanting to get more senior, this is something that can help you get to those senior roles. Some of those things that can help you think through some of the steps that will help get you there, some of the decisions you might need to make. And for those people at that senior and principal level, it also helps to put some of the things into words, because I know for a lot of us, we get to those senior levels and we never really think about how we know what we know. We just kind of know it. And then we say, this is what we're going to do. And then people look at us like we're crazy. So it's very helpful to put our things into words and that we can share our vision with others. Now, the quick bit of housekeeping and disclaimers. So, throughout all of this, except for that picture of Uluru plus a few others where credit is due, all the images are using generative AI, because of course they are, and we can be a little bit clever with that as well. And the other part of this, because of the nature of my work, like many people in consulting, we do want to keep things confidential. I do want to share a couple of stories, but I have also changed the names, sectors, and some of the tech to try and keep things a little bit anonymous. So, with that, we'll get into the meat and potatoes of today, but I will say, this is meant to be a bit of a discussion session. I want to hear from each of you as well. I don't just want to be up here pontificating, blah, 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 yap, end of the day. If you've got something you'd like to share, if something's triggered an aha moment, if there's some little story you'd be like, this is relevant, I want to share this, please do throw your hand up. We've got some of the fantastic volunteers around with microphones, and we'll hand those out as well. And if you feel like heckling, feel free to do that as well. All right. First thing here. Now, congratulations, you're starting out in your new role as a developer. Now, the first thing that we all like is we all have our languages of choice, we all have our frameworks and our tools of choice. When we get to our job, what's the first thing we find? We probably can't use all of those. How do we do front end here? Can we use SvelteKit? Can we do all those things? No, we use Angular. Our back end, can I build something in Go? That would be awesome. We use Node.js. And what about design? Can we have our own design system? Can I build my own design system? No? Well, I like this. Someone's already picking up the theme. No, we use Tailwind here, or we have our own custom thing. Welcome to the world of constraints. Constraints are a fantastic thing that permeate everything that we do in tech. And I think it's best to try and explain this with a bit of a picture. So if I'm talking to people and we've got sales going out, we'll try and do things and talk about, for example, we can be good, fast, or cheap. You can only pick two, but that's never how it really goes, is it? These are good examples of constraints, because two of the biggest constraints that we ever deal with are time and money. Those are two of the most common constraints that we deal with. That forms the framework of a lot of the decisions that we make. But often constraints go a lot deeper than this. Thinking about a few of these, we've already talked about a constraint that we deal with in tech as developers and as engineers. That's our tech stack. We don't get to choose those. Those are already made for us. There's also a lot of other constraints. I won't go through all these because these are just a few I'd want to throw on a slide, and there's many, many more. But these are some of the things that pop up as constraints for us. We get told, you must do X because of Y. You must fill this because of that. So, the interesting thing is that constraints aren't necessarily just hard lines that we are stuck against. They can also be a little bit more permeable as well. I want to go with one of these, thinking about the constraints of being geographic. Now, all of us are Australians here, I believe, and one thing we hear a lot of in Australia is data sovereignty. Familiar? Yes? Nods around the room. And that's that we keep data within a certain sovereign area. Now, one thing that we hear a lot of is we have to keep data in Australia. That's a fairly common thing, yes? Nods. There we go, not everyone's asleep here. Love it. Excellent. Now, what we also sometimes hear is that data can only be kept within a certain state, like here in Victoria. So here's some examples. Let's go with a large retailer. So for this large retailer, their presence is entirely based within Victoria, all these different places around, and they say, because we are Victorian-based, we must keep our data within Victoria. Of course, I'm a cloud person, so okay, that's interesting. We can do stuff within Victoria alone, but it's a little trickier, isn't it? But when we come down to it, we can ask the question and say, why is this? Because that's what our legal team say. Why? Because that's where our data is. Why? Because that's where our users are. Why? I don't know. That's a good question. So when we dig at those constraints, sometimes we'll find out that that's not really the constraint. And in this case, well, we'd like to keep it in Victoria, but we don't really need to. So sometimes asking those questions takes us into interesting places. But equally, sometimes things can surprise us as well. Let's say for a small non-profit, the same thing. Our data must be held in Victoria, there is no exception, etc., etc. Okay, yes, lovely. Okay, we'll go and ask the question, etc., etc., etc. And eventually we get to the point, oh no, there is actually a requirement in our contract and funding from whichever local government area that stuff has to stay within Victoria because that's how their legal department wrote it. Okay, well, I guess we have to deal with that one then. So constraints are an important thing, and I guess no matter what your level of seniority is, you're always working within constraints. One thing is that sometimes they're well specified, other times they're not well specified. And sometimes asking those questions can take us to new and interesting places. I guess throwing this to the room, does anyone have any particular experience with weird constraints where they've bumped up against stuff? I've seen a few smiles, nods of the head. Would anyone like to share anything? I'm very keen to hear some stories from the floor as well. There we go. Oh, I saw it.
We build on Microsoft Dynamics. We build on Microsoft Dynamics, and that's a big constraint because we're limited to what Microsoft do for what we can do. So that's a big constraint from us.
There we go. We're limited by the platform. And I guess in those cases, have they given you any flexibility to say that we want to do stuff outside of that? Would you be able to do anything outside of that, or is it a pretty hard constraint? Pretty hard constraint. I guess from that as well, thinking about that, do you find that that limits what you can do as well?
Yes, and what we can build and what text we can use. So that's a really big limiting factor for us.
Interesting. And so that's a good case of a constraint where it does pop up and it becomes a bit of a thing because of our tech stack. Has anyone found situations where we might find a constraint that maybe isn't a true constraint? Things where when we dig deeper, it's not quite as bad as we think. There we go, we got one down the back as well. Excellent. And thank you to our fantastic volunteers for taking this when I came up with the idea of yes, we'll just talk at stuff random times.
Thanks for running so far. I work in finance, and there's always been this constraint about auditing and paper forms.
Yeah.
But when you dig into it, the requirement is evidence that something has been provided, not so much that it's made of paper.
There we go. But of course, the natural inclination is that paper is going to be the best way to get evidence, wouldn't it? But that's not the only way, is it? Yeah.
It's not.
Interesting. And I'm guessing that, again, frees up a lot of stuff as well. Another one over there. Yep.
When people think they must be multi-region, but actually multi-AZ would be fine. If
Yes.
you explain to them what the guarantees are on AWS. Yeah.
I see a few smiling cloud people here who've heard this one as well. Because, of course, multi-region adds a lot of complexity, doesn't it? Yeah. Matt.
Hello.
Hi.
My favourite one is we must be multi-cloud in case our cloud provider goes down.
Oh, yes, there we go. And that adds a lot of constraints, doesn't it? Because suddenly we have to build our solutions across cloud, and we can't take care of them like our cloud-native solutions, can we? Stuck with things like Kubernetes. So that adds new constraints, even though we want it to be a little bit freer. We add more complexity.
My favourite one is around deployments, and the person who wrote the code can't be the same person to deploy it, or that it has to go to a different team, and then you kind of realise it's actually not that
Yeah?
bound. It's just suits the structure of the business, not the actual laws that sit behind it.
Yeah, and I guess that's an interesting one, is where something might be taken as this is mandated by legislation, but in fact it might not be, because, well, maybe that's not the case. Yeah. Awesome. Those are some really good examples, and I guess the whole thing for today is not to say this is exactly how to think of it. Just let these stories fill your head, and these might be things that just pop out of your brain at some various point in time, and hopefully they'll be useful. Now, constraints are really useful because they can inform us also what could go wrong if we don't do something right. This leads us to a fantastic world called risk, which looks something like this. Let's not talk about that. Let's make the risk a bit simpler, because I'm already thinking we might be sending people to sleep as is in this nice warm room. And that's thinking about risk from the most basic elements. How likely is something to happen? And what's going to happen if it happens? At the end of the day, that's what risk is about. And while there's many different ways to calculate it, I think there's a few misconceptions that happen when we think a little bit too intuitively about risk, and we don't sometimes look at it as closely as we otherwise might. Let's go with a cloud example. We seem to have a few more cloud people in this room as well. Now, this will be a bit of an AWS 101 around reserved instances. Now, don't worry, you don't need to remember all of this. This is just a bit of a concept discussion, and there are many other ways to do these sorts of things. So for anyone who doesn't know, a reserved instance is a billing discount that you can get on AWS. If you run a certain amount of a certain type of virtual machine, you can get a discount if you commit to using it for a certain period of time. Lovely. Now, we can commit to that for either 1 or 3 years, and we can either pay for that fully upfront, we can pay for it partially upfront, or we can pay it all just on a per month basis, and we just pay a lower amount. So, that's how that looks. In a bit of a case of how this might look in a typical solution, we have something like a database system. So we have our primary server sitting on, for example, a nice M8 4X large, blah, 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 words. So we have that as our reserved instance because we probably think our database, our primary server, we want to keep up at all times. Other things like our read replicas, maybe that can be a little more flexible. We want that to be on demand. We don't necessarily need to be running it all the time. So this is the framework of just how we want to think about risk in this context. So let's give it a scenario. Here's our particular server. We have our C6G4X large words. This one's got 16 CPUs and 32 gigs of RAM. It's a fairly beefy-ish sort of VM. And here in Melbourne, per year, it would cost us about $6,000 to run in US dollars. So a little bit more in Australian. A lot more in Australian at the moment. Now, when we look at this, running a single virtual machine costs us $6,000 a year. That is expensive. Cloud is costly. Let's go back on-prem. I don't think so. Now, this is where things like reserved instances come in, where we can get those discounts because we're going to use it for a longer period of time. So, if we want to pay nothing up front, over that 1 year period, it drops down by a fair chunk. Or if we want to put it up to 3 years, then on that per year basis, it drops down by quite a bit further. And of course, if we were to do something like all upfront, we get slightly more discount, and partial upfront throws us somewhere in between. So that's a bit of an idea there. But we can see there's not really much of a difference between whether we're doing no upfront or all upfront. Realistically, it's not too different. Now, let's reorient as to how we tend to think about this sort of thing mentally when it comes to reserved instances. So when we look at our perception, this is how we tend to think of it. Now, when people look at this and start saying, let's do your cost optimization in cloud, what do we tend to want? Should have kept that microphone. We tend to want the biggest cost optimization. We want to have the biggest cost optimization. Now, if I go to my boss and say, hey, I want to pay for this thing 3 years all up front, we're going to pay like however many tens of thousands of dollars right now, yeah, that could be too expensive for us at the moment. Now, realistically, that translates to it's a bit too risky. What if we don't use it? What about 3 years partial up front? Probably the same. 3 years, probably the same. 1 year, probably the same if we do it all up front. So we'll probably just slide right back to the default, right? We'll probably just stay on demand. We don't want to introduce new risk. It's a little risky if we start doing this. Now, this is how we do it when we are thinking fast. When we look at this in our head and we think, yeah, this is all pretty well together. Let's slow down our thinking and look at it from a bit of a value base. If we map this out based on what the discounts actually look like, we see here that this starts shifting around quite a bit. And something like our 1 year no upfront has relatively minimal risk overall, and that it has a fairly high reward if we consider we get a third off the price, potentially more. So by thinking a little bit slower, we start to see there's actually a fair bit of difference in that risk when we look at it a little bit more closely. Now, if we look at this, let's think about how risky these options are. Now, I'm going to call out to the room, we won't worry about microphones for this. Let's just go for like a shout out. So, how risky in this case is the 3 year ones? Low, medium, or high? High? Awesome. Cool. What about the 1 years? Medium, low, or high? Medium? What about on demand? No risk? Low risk? What would you think? Medium. Low? Medium? Ooh, there we go. Availability, there we go. Thinking deeply about it too. But yeah, so that's kind of like the low risk, no risk end if we want to run something for 3 weeks. Because the way we've approached this so far is, what if we don't run this for very long? What if we're just running this for a few weeks? We could potentially lose a lot of money. It starts to spin a little bit if we end up running this thing for 3 years. So, let's have a bit of a look at some numbers. Yay, numbers. So we'll compare the 3 year no upfront to the 1 year no upfront to that 3 year all upfront. Now, obviously, if we run this for 3 weeks and we don't use all of it, that's going to be wasting a fair bit of money compared to if we run it on demand, where it costs us basically peanuts. That's the whole point of cloud. If we don't run it for long, we don't pay for it for long. Lovely. If we run it for 3 years, on the other hand, now, obviously, 3 years all up front, we're using it for 3 years. Perfect. Low cost. If we do our 1 year no upfront and we just purchase 3 of them, keep our flexibility, we're paying a bit more, but that's still not too bad, especially compared to if we left on demand and our costs suddenly look something like that. So if we were running something for 3 years and we decided to stick with on demand because we weren't too worried about this, and we were thinking we just want to stay away from any risk, suddenly introduced a whole new risk. We could be paying a whole lot more. Now, of course, which one are our bosses concerned about? Probably less about the second one than the first one. But this is where us slowing down, thinking about the risk from that perspective, it throws a different sort of slant on it. Now, if I was to have a look at this as well, there's also a break-even point here. Now, if I was to run my 1 year no upfront reserved instance, only for 7.5 months, I'd still be breaking even. Anything more than that, I'm coming out ahead. If I run this thing for only 8 months, I'm still saving money. Now, going by this, off of today, the break-even date would be the 10th of October, a Friday. We don't want to do anything on a Friday. Now, I would probably suggest, and tell me if I'm unreasonable here, if you don't know if you're going to be running a system just by October, I probably have some more questions than just what you're doing for cost optimization. Fair? All right. Now, this is all just in one reserved instance. Typically, we'll buy a lot of them, and then we parcel out the risk amongst that. So thinking slowly helps us to unravel the truth a little bit there. Does this sound familiar to anyone where they've dug into risk and they've started to find that when you look more closely, things aren't as bad as they seem. Sound fairly familiar? I'll go with some nods if there's things. Possibly. Is this completely new to people? Have I kind of shocked people's worlds here? I'll take the laugh that this room's warmth is getting to us all. That's all right. Because the other thing for this is that it helps our finance people from feeling crabby by able to talk about our risk a bit more holistically as well, because this is the language our finance people talk in. But speaking of crabby, what's this thing? There we go. Ferris the Rust crab. Now, Rust is a great language. It's got a lot of things going for it. It's pretty cool. But when it comes to every enthusiast who's dealing with Rust and gets into a production environment, what do they say? Can we rewrite it in Rust? Can we rewrite this in Rust? Now, let's take our little TypeScript application here. We've got our nice advertising platform. They've got their TypeScript backend, nice React front end. TypeScript is crap. Let's rewrite it in Rust. So, me coming in as the engineer, here's what I'm going to show you. This is the reasons we should rewrite it in Rust. It is so safe, so blazingly fast. It's the most loved language ever. We even use it in the Linux kernel, Tokyo, fearless concurrency, all those things. As an engineering manager, what are you seeing? Anyone want to shout out what they might be seeing here? Cost? Risk? Yeah? There's no negatives. That's a good one. When people present something without any counterbalance, that's a good sign they might be not entirely informed. The way I kind of think of this one is we might be seeing something that looks a bit like this. A giant dumpster fire. Because there is a lot of time required in this. Suddenly it's going to be a very lengthy process. We're going to be rewriting across language paradigms. Writing in TypeScript is very different to Rust. And ChatGPT won't help you for all of it. There's also the potential for scope creep. Well, if we're doing this in Rust, could we also do all these other things too? We could just rewrite everything. We could add new features. It's awesome. What about the platform capability and maturity? We've talked about this as well. If the platform isn't capable of it and the platform supporting isn't mature enough, we might be adding more problems to the mix. Our teams might not be familiar with how to write Rust. Shockingly, not everyone loves Rust. Not everyone knows Rust. And of course, the unknown unknowns. Now, I think it's safe to say that if engineers were to say to me, and I'm wearing an engineering manager hat, let's rewrite our platform in Rust, what am I probably going to say? No. Exactly. I could have gone for a real spinner and just said, yes, because Rust is amazing. All right. Now, this is because in this case, we're talking about the entire platform stack, right? I think we can all agree that's probably not the best example. But what if we were to rephrase and rescope this a little bit? What if we were to think about this in the context of a single service or tool? So a bit of an example here. Let's say we had a team, they had a couple of people, they were pretty into Rust, okay, they were pretty into it, and they wanted to set up some tooling for one of their DevOps pipelines that was bespoke to them. They want to write that in Rust. Contained to that. What would we say then? Maybe, yeah. Why would we maybe say that? Yeah. Yeah. Contained only for them, not likely going to affect anyone else. Yeah. No. So I'll yeah, so, and that's the thing, is that we might need more people who know Rust if, what if those people leave? Yeah, that's definitely a thing. Awesome, and I guess that's the thing, is that it's still a risk, but in the context of this, it might be an acceptable one, especially if our developers feel strongly about it, because, okay, worst case, people build it in Rust, they're happy, they leave, they want to go write Rust somewhere else, lovely, good for them. All of a sudden, no one knows how to service the tool anymore. What's the worst case? There we go. No, we rewrite it in Go, excuse me. Yes. But that's the thing, we can always rewrite it. And for something like that, the scope is not massive. It's fairly straightforward to do. And worst case, this tool works well, people enjoy it, other people want to get on board with it. Maybe there is a case there. And realistically, as an engineering manager, keeping devs engaged is a hard challenge. So if you can give people space to just say, it's like, yeah, I want to do something like this, then all right, go for it. So for the developers in the room who want to tackle some new technology, get inside your engineering manager's head, you'll be able to do some really interesting things. So, does this spark anything for anyone? Has anyone wanted to rewrite something in Rust? Has anyone written anything in Rust?
Wanted to, yes, and also, changed tooling and pipelines and stuff to TypeScript to Rust, yeah.
There we go, from TypeScript to Rust. Well done. Excellent. Cool. I think the key point to this one is that even if we make this decision, even if we accommodate the risk, it's not the worst. Why? Because we can just reverse it. It's not too much of a cost if the thing goes bad on us. We've made the risk assessment, not the biggest problem. Leads to this concept of reversibility. Now, this is something I've very gleefully stolen from Amazon. I can see a few people with AWS shirts here, and I know there's a couple of Amazonians, community builders, heroes in the room, so they might be familiar with this one. This is the concept of one-way versus two-way doors. Now, in this case, we have a two-way door as being something we can walk in and then walk right back out. So that last one was probably a decent enough example. Let's go with another one, though. Let's go with something where we can't easily walk back out, and we might have to take the fire escape. So, let's go for the example of a government department, and they want to create a new proof of concept web app. It's going to be cloud native. It's not going to be like the stuff we've written before. It's going to be cloud native. It's going to be the bee's knees, do all these things, fantastic. Now, in a lot of cases, this might just be a one-way door decision. We build it, it doesn't work, shmeh, whatever, big loss. In some places, though, there can be a lot of architecture gates. There can be a lot of approvals just to build things because who knows what this thing could be doing. This thing could cost us a lot of money. We want to jump through a lot of hurdles to make sure we really have considered this thing. Suddenly, if time is a resource and we're spending a lot of resources on this, suddenly it becomes a very big one-way door even just for our proof of concept. Because suddenly this becomes quite a challenge. And the important thing here is also knowing which door you're going to be walking through, understanding if the decision you're making is one that's easy to reverse or it has longer-term impact, and also knowing which one you're asking your boss to let you walk through as well. That's an important one because you can also convince your boss if the decision's reversible, then maybe it's not worth them just pushing back on you. Maybe it is just worth you going for it. But the important thing to this is in this concept of the one versus two-way doors. Now, for the two-way doors, it's pretty low cost to reverse your decision. And those costs can come in a lot of forms. Obviously, money is a big one. We know that one. Time is a big one. But also in things even like political capital. If I want to make a big push to do something in an organization, and we're going to start doing something like rewriting in Rust, for example, if we commit to that and it blows up in our faces, suddenly we look a little silly and it's kind of hard to do things now, isn't it? So that's a bit of a case of the cost. Because a one-way door is something where there is a high cost to reverse the decisions once they're made. Doesn't mean we can't reverse them, it just means there is a much higher cost to it. The good thing about two-way doors, they let us innovate a lot faster because we can just dot through things, make lots of small decisions, see where you go, and either you'll end up somewhere good, or worst case, we take the wrong turn, not so bad. The good thing for one-way doors, though, is that if we have really critical decisions, things that might make a lot of challenges. Like, for example, we want to rewrite it to Rust. We want to do a cloud migration from on-prem into AWS, or into Azure, or into GCP. Those are fairly big decisions because there's a lot of things involved in them. So we want to make sure those ones are well assessed. For two-way doors, the main thing is we just want to assess, control, and really accept that the risks are there. We'll never be able to get rid of all the risks. We can't get rid of all the risks for anything. I could fall right off this stage and then the organizers be in a lot of trouble. They can't really eliminate that risk. See the volunteers shrugging, I'm sorry. We love you. But the whole thing is that we accept the risks around that. We accept the risks that I'm probably smart enough not to fall off the edge of the stage, and that I'm standing far enough away from the edge. The thing of those one-way doors is that we also have to assess those risks, but we also have to assess the risks that if we have to go out the fire escape, that's going to be fairly costly to us. So, when it comes to management, if you want to be able to remove those barriers and maximize speed, make sure that what you're building are two-way doors. Something for our managers in the room to think about as well, and for our senior engineers. But also to that, one-way doors are very useful. You should implement them where there are critical risks that you must control. These are really, really important things. But if there's no real cost to it, try and make it more two-way doors. People will be able to innovate more, they'll make more mistakes, and as a result, they'll learn more. Lovely. And even on the organizational scale, we think a couple of years back to something like Facebook, they made a really big one-way door decision when they decided to tie themselves to the metaverse. Really, that's all the snickering I'm getting out of that? I was expecting bursting out laughter, my God. Because they shot themselves in the foot quite heartily. Even if I look at Amazon, obviously look at the just walk out technology. Troublesome. But Amazon also made a big bet when they created AWS in the first place. Microsoft made a big bet when they went down the Azure path and everyone decided to go for cloud computing. They paid off massively because they were well-considered risks. Now, that brings me back to the end of my talk. I'm sorry, you'll all have to start waking up a bit now. But I guess if people here are the book types, there are a couple of books that kind of influence a lot of my thinking around this. So if people want to grab photos, if they want that sort of stuff, awesome. Reach out to me on LinkedIn, all the normal bits and pieces there. I'll give people a moment to have a look at that. But otherwise, that brings me to the end of the actual presentation, about 12 minutes ahead of schedule. There we go, the volunteers are happy with me. This is important. But for this, I will say one important thing. While we are here, I'm going to give you a little tip. While we're here, I do want to say a big thank you, obviously, to our sponsors and our fantastic volunteers. So can we get a hand to the volunteers as well?